Hello, hello. Jiki is here. Today we're going to talk about the flowcharts as a problem-solving tool in programming. So this is the video presentation for Introduction to ISC class. Let's dive in. So what is actually a flowchart? A flowchart is a visual representation of a program or process that shows each step in a clear and logical order. So it uses different symbols to represent actions, decisions, inputs, and outputs, which help us to illustrate the flow of control. Why do we use a flowchart? So, flowcharts are helpful because they clarify the sequence of steps in a program, reveal the potential mistakes or edge cases, and provide a simple way to communicate logic to others. So, it means if you are aware of some syntax of any programming language, let's say you don't know how to write code on C++, C, or Python, maybe you don't know JavaScript, but if you can understand, like if you are able to read the flowchart, you can understand the whole logic. For example, if someone in your group wrote a code on, let's say, on C++, but you don't know C++, like you don't know how to do anything, you don't know how to write a code, a single line of code on C++, but your friend who wrote the code has a flowchart and you're pretty good at reading flowcharts. So you just go through the flowchart from start to end and you can understand what their code does. So importance of planning in programming. Planning is one of the most important things. By good plan, you can save good amount of time. So planning is a critical step in programming because it allows developers to organize their thoughts and visualize the logic of program before writing any code. Before jumping into coding, you should first of all make some flowcharts. Like without logic, you cannot code. So flowcharts helps you to identify what logic and what things to use. Be sure to make a flowchart before starting to code. So visual representation of logic. Flowcharts make it easier to identify potential errors, clarify complex sequences, and communicate ideas effectively to others, even without knowledge of a specific programming language. As I mentioned in previous slides, even if someone don't know the syntax of any programming language, but just being able to read the flowchart or make the flowchart can help you. So, key symbols in flowcharts. Flowcharts use a few standard symbols which are like this: oval, rectangular, diamond shape, parallelogram. So, ovals are used to represent the starting and ending point of any program, of any flowchart, while rectangles indicate process or instruction. Diamond shape is decision making part. Like consider diamond, if you consider diamond shape as a if statement. Every time you see the diamond shape, just know that it means if and else. For instance, if you want to identify whether the number, let's say 5, is positive or negative, you just ask if 5 is greater than 0. If yes, it's positive. If no, it's negative. Every time you make a flowchart, be sure to use arrow. So without arrow, it won't be a good flowchart. So now I want to show you an example of how to like make a flowchart and how to write a code based on this flowchart. So we have a statement. In this example, the program asks the user how many numbers they want to input and process each number individually. For every number entered, the program determines whether it's even or odd. So instead of printing the result immediately, the program stores even and odd numbers separately and displays them at the end. This approach demonstrates how to use loops, decisions, and dynamic storage with vectors in C++ to organize efficiency. So this is the algorithm of flowchart, and these are the 10 stages which our flowchart will go through. As you can see, it starts from the step 1 and ends with the step 10. So it like goes from start, asks user to enter the iteration number, inum. We're opening even and odd arrays. We are making I. This one is a counter to equal to 1. And every time we check, this is decision if. Remember I told you if you see if or if you see diamond shape, yeah, diamond shape, it's if. And every time you see if, you can know that it's diamond shape on a flowchart. So this is a flowchart. These are the stages which were mentioned here. And based on these stages, this flowchart was made. The flowchart begins with a start symbol, then prompts the user to input the number of values to process. Two empty vectors are initialized to hold even and odd numbers. The program enters a loop. Here is a loop. As you can see, this is the loop part. It checks if is I greater than the number I entered here. You know, as you can as you can remember, first I said user inputs how many times our loop will work. So here on the fourth step, it identifies, it checks if the number of iterations of loop are greater or less than the number I inputted, like user inputted first. So the program enters a loop to the process each number. The user inputs a number and decision symbol, checks whether it's divisible by 2 here. It prompts user to enter the number, and here again diamond shape checks if divisible by 2 or not. If yes, this is added to even, if no, to odd. So after all numbers are processed, the program prints all even numbers and then all odd numbers, concluding at the end symbol, coming to here. This flowchart illustrates how dynamic data storage integrates with program logic. So this is my code I wrote on C++ syntax. As you can see, I have integer n, x, and vector integer as even and odds. So it is actually like here, how many numbers do you want to input? Here, how many numbers do you want to input on the terminal? In this example, we have 5 and entering 5 numbers. 2, 3, 5, 4, 6. As you can see, evens are 2, 4, and 6. Odds are 3 and 5. So this is the loop part. Like loop iteration works like I. The step of loop equal to 1. It works until the number we entered is greater or equal to I and I plus plus. So every time inside the loop we enter the number and it checks if it's divisible by 2 or not. If it is divisible by 2, it push back. We use pushback function to append to this list and pushback function on odds to append for odds. So, summary. This example demonstrates how a simple problem can be handled efficiently using loops, decision making, and dynamic arrays in C++. So, this was the end of my presentation. Thank you for watching.